Okay, we are back. So we are looking at now a graphical look of a differential equation. And so today we're going to talk about slope fields, and then we're going to also talk about what if you don't have just an x here, but you have an x and a y. So we have something called a slope field in calculus. And a slope field is a kind of an XY axis, and you're going to be provided few points. This one's kind of a lot of points, but on your AP exam, I would say 9 points, maybe 6 points or 9 points. And what the slope field is it is a basic plot of short little line segments which have a slope defined by dy dx, because that's what the slope is. And I know it's kind of hard to understand, but like if we graph all of what the slopes look like, it generates this field of things that provide us with what the original equation looks like. So let's do one, kind of pull it all together. Let's talk about first how to do this. So you're going to want to maybe get a little ruler out. You don't have to be perfect. You're like on the AP exam, they will really hammer you if you don't have your slopes that are like the zero slopes, right? And the positives and the negatives. But they're not going to be getting a ruler out and double checking that your rise over run is perfect. If there's an x and a y, you have to plug all of the points in. But let's just do our points for equaling 2y. And we take a point, for instance, this is the point that is 2, -2, and I would have to plug 2, -2 in for x and y. Well, there's no x, so I'm just plugging in y. What's 2 times -2? It's -4. So I would say then dy dx at 2, -2 is going to equal -4. And then I am going to draw a little mini line with a slope of -4. To do that, I'm going to kind of go like, let's see here, 1, 2, 3, 4 over 1 would kind of be about this steep. And then, okay. Now, here's what I'm going to do. I hope you would agree with me that wherever y is -2, the slope is -4. So instead of like doing this all over again, I'm now going to cheat and use that -2, any y value of -2, and I'm going to just drag my ruler over and make it have the same slope. Okay, so there's a little line segment with my slope of -4. I'm just going to try to make them all the same there. Okay, all right. Let's move up to this point. This is the point 2, -1. This is just a downward stroke. That's a shorthand notation for at the point 2, -1. I don't know if I've shown you that before. Again, I only have the y value. I need to plug in -2. This would have a slope of -2. So I'm going to try to draw, and at all of the -1y values, it's going to have that slope. So I'm going to take the point 2, -1. I'm going to kind of go up 2, back 1, make it about this steep, and then I'm going to make all of the lines have a slope like that. Now, they're not always going to be where the y is the same, but if you figure out a pattern, use that pattern to kind of cheat so you don't have to do, in this case, it would have been like, how many points? 1, 2, 3, 4, 5. Yeah, 27 points. Not good. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 25 points. Okay. What about when y is 0? Let's not do work here, guys. When y is 0, 2 times 0 is 0. A 0 slope looks like this. So we're going to make little lines that have a slope of 0. All right, let's go on to the other side. I'm going to look at the point 1, 1. The y value is 1. I plug in my y value of 1. 2 times 1 is 2. All of the lines when y equals 1 are going to have a slope of 2. So I'm going to go back a little bit again. Make them all be the same. And it's pretty clear like this one, these are steeper than that. That's kind of what they're going to be looking for. And then the last row, is the point, 2, 2. That has a slope of 4 because 2 times 2 is 4. And so I'm going to use my rise over run. 1, 2, 3, 4, 5, 1. Okay. And make slopes of 4. And again, guys, can you tell that these are steeper than these ones? That's what we're looking at. Okay. Suppose that you know that the point 0, -1 is on the particular solution. By following the slopes, draw on the diagram above what you think the particular solution looks like. Now, this gets tricky when you only have this many points. But to me, this is a horizontal line, and these things are going like up like this and down like this. I wonder if it goes through 0, -1, and it's got to be horizontal. This looks like potentially this could be something that's exponential to me. Okay. All right, potentially that could be something that's exponential. Let's see if it is. Okay. Next, solve the differential equation. I mean, in how I did yesterday. How would I do that? Okay. So now what's happening is this looks exponential. That's not, because this is its slope. Okay. What I'm going to now do is I'm going to actually find what the equation is and see if in my head that matches what I'm seeing here. So how we do this, I'm going to do another example after I do this one because I want to do one with an x and a y. We do what we did yesterday, and we need to have the y go with the dy, and the dy is already on the top here. I need to divide both sides by y to get the y to be over here. And I also need to get the x over here. So the first thing I'm going to do is I'm going to move the dx to this side. The dy has to be on this side. The dx has to be on that side. That cancels. I'm going to then leave the 2 here. You don't have to, but you could bring the 2 with the y. You're going to get the same answer either way. But I'm going to leave the 2 with the dx, and I'm going to move the y to the other side. That means I'm going to divide by y, or multiply by 1 over y. And over here, I just have 2 dx. This is what we call the separation of the variables. I pulled the y over here. Now, if there were an x with this, we'd leave it over here with this. Once you get a y thing with a dy and an x thing with a dx, we're then going to take the antiderivative of both sides. So I'm going to add that into the mix. Then, using some of my rules from yesterday, let's think about this. Some of my rules from yesterday. 1 over y is natural log. So the antiderivative of 1 over y is natural log. Now, y has to be positive, so I'm going to say the absolute value of y. And what's the antiderivative of 2? It's just 2x. And then there's some constant. Like, seriously, there's a constant on both sides. But the reality is, if, let's say there was a number here and there was a number here, I could just take this number over here and move it to the other side. So don't write a c and a different c over here. Let's just put one constant, and we're going to put it with the x over here. Okay. So at this point, I am going to solve for y. But before I do that, I am going to plug in the point that I was initially given, which was 0, -1. Okay, so in the point 0, -1, I am going to plug 0 in for x and -1 in for y. And so I go back and I look at this, and I have to be just a little careful. We're going to solve for c right now, but understand here that when you drop out an absolute value, this could be a plus or minus situation. I'll get to that in a second. The natural log of the absolute value of -1 is natural log of 1. 2 times 0 is 0. I hope you know that natural log of 1 is also 0. That means c equals 0. Okay. So if I put 0 in here, okay, now I have natural log of the absolute value of y equals 2x. Sorry, 2x plus 0. So how do I undo natural log? I write it as an exponent. So I have e to the 2x, e to the 2x equals the absolute value of y. Now, normally I would just say, hey, drop the bracket. But do you remember how y over here was negative? So this just means y is going to either be plus or minus e to the 2x. Because the output of this one was negative, I'm going to pick negative e to the 2x. Looking up at my graph, I hope you can see this looks like an exponential function that's flipped upside down. And so that matches what I see on my graph. Okay. This is something we're going to continue working on today. We're going to mostly sketch slope fields today. I'm going to give you a couple separation of variable ones to try today, but this is going to have to be something else so that we solidify next week. So let me just see if I have some room or some space somewhere, which I do. I'm going to do one on the back to solve another one that's a separation of variables problem that has both an x and a y, so you can see what that would look like. Okay, so suppose we had the differential equation dy dx, and this time I'm going to tell you it equals 2xy. And let's say I want to find a particular solution. That goes through the ordered pair 0, 2. All right, so I go through and I'm going to my separation of variables, and I need my x. You're always going to move the x because it's on the bottom of the fraction, so you're going to always move it over here. So I'm going to move the dx to this side. I now need to move the y, and again, you can choose to keep the 2 with the x or the y. It does not matter. I choose to leave it over here more often just because it would be nice if y was alone when I moved it. I'm going to divide both sides by y. By the way, if y is on the bottom, you would multiply both sides by y. When I divide both sides by y, I once again get this 1 over y. Over on the right, I have 2x dx. Okay. Once you've separated your variables, now you move on to taking the antiderivative of both sides. So the only difference this time was this actually, the x stayed here with the dx. The antiderivative of 1 over y is once again natural log of the absolute value of y. The antiderivative of 2x is x squared. We have a constant and a constant. I'm going to choose to put my constant over here. Once again, I need to find my particular value. This is when I plug in my 0.02. So I plug into natural log of the absolute value of 2 equals 0 squared plus c. That leaves me with c equaling natural log of 2. I'm going to leave it as natural log of 2, and 2 is in the original problem. It was positive, so natural log of 2 is what c equals. And I'm going to leave it that way. All right, so I'm going to go back up to this step right here. I now have that the natural log of the absolute value of y equals x squared plus natural log of 2. And now I'm going to solve for y. If you get to your AP exam and you get all the way through this whole thing, and this is your last step, like it's minimal points to get all the way to the end. The most points is the separating, the antiderivative, and the finding the constant. I point that out because sometimes you get some pretty crazy things over here. This one's not too bad. I am going to get y alone by writing y, the absolute value of y, equals e to this whole side, x squared plus ln of 2. Now, to remove this, y equals plus or minus that. Because the initial condition this time was a positive value of y equal to positive number, I'm going to take that out. This is just positive. You don't have to write it in there. Okay. All right. This is amazing if you get it to this far. One extra little thing that's fun about this, I don't know if you remember, that there's a rule about exponents, that you could write this as e to the x squared times e to the natural log of 2. I don't know if you remember that rule, when the bases are the same, you add the exponents. That would allow this e and natural log to cancel, and then this would just be 2e to the x squared. Once again, if this were an AP item on an AP exam, they would accept this answer. This looks a little prettier. All right, so I'm going to give you some questions to try, and we'll reconvene again tomorrow. I'll have another video about another particular solution tomorrow.